Maybe we want to grow the number to about 50 before we start? Or we can start. So, President.
We can start, sir.
Okay, thank you everyone for joining our webinar today. This is the second in the Knowledge Series webinar 3.0. The topic for our discussion today is counting carbon. And as we have advertised earlier on, it's going to be an interactive session. We have our resource person, about 4 of them, around to assist us with this webinar, and they are all already on the call. They are experts in the field, and I'm sure that we're going to have a good time. So I welcome you all to this webinar, and as you know, GBCN, we have a lot of activities that we do to enlighten our members so that we get new knowledge, new information about the built environment, and how best we can assist in fighting contributing our own quota to climate change, mitigating against the effect of climate change. GBCN will run courses. We run courses in the area of carbon assessment professional course, certified carbon assessment professional course. We also run green building professional course. The next series of courses will be advertised soon and you'll be contacted. But to get our work started today, we have 4 gentlemen in the house who are going to serve our resource person. I'm going to call them out, just a brief introduction of them. I have Dr. Sanmi Olowosile, who is a visionary leader with a passion for sustainability and a voice for climate action. With a background in construction and environmental management, he is dedicated to his life to bridging the gap between industry and environment. He is a lead for City and Community Pro, and he holds a numerous degree and certification in sustainability, including a doctorate degree in sustainable growth from Commonwealth University College. Is ISO 14001-2015, ISO 45001-2018, and Occupational Health System Management expert. The citation is long, but I think because of time, we'll just take that. He's an expert in the field. I have next to him, we have our in-house consultant, architect Sangeeta Ramaraj. She is an holistic sustainable accelerator driven by purpose and passion. With over 5 years of experience as a sustainable architect, she has earned her skill in green building assessment and audit, laying a strong foundation for our transition into the dynamic field of ESG reporting and management. The next is Dr. Olubukola Tokede, all the way from Australia. Dr. Tokede is a life cycles certified assessment professional of over 10 years of work experience with a strong commitment and track record in integrating life cycle sustainability thinking into building and infrastructure projects. He is the initiator and research lead of Thinking Building at Deakin University, Australia, and the Cradle to Cradle research team leader of Life Plus Smart Lab, Deakin University, Australia. He has had previous experience as a construction engineer and critical reviewer for life cycle assessment of infrastructure projects. Last but not the least, I have Mr. Mohammed Abdusalam, who is a consultant with VAT in the UK. Mr. Mohammed is a LCA consultant at VAT, responsible for conducting life cycle assessment and integrating circular economic principle from early planning stages to handover. He undertakes LCA and LCC analysis to enable design team to make informed decisions that reduce life cycle carbon emission and cost. So nice to have this gentleman on the call, and I'm sure we're going to have a good time with them. Before we go ahead, Mr. President, are we having a message from our sponsor?
No, we won't be having that. So we can just go straight to the presentation.
Oh, okay. So we go straight to the our presentation. We'll first have our presentation. Thereafter, we'll go into breakout session into where we are going to do simple exercise of calculating the embedded carbon in building assembly. So I will now invite our presenter, Dr. Olubukola Tokede from Deakin University, Australia, and is going to talk to us on understanding the old carbon, life carbon in building. Dr. Tokede, you are welcome. Thank you.
Okay, good afternoon, everyone. And it's 11 p.m. here in Australia. So thanks for keeping me up late. I'm deeply honored to get the opportunity to speak. And I really want to thank and express my appreciation to the Green Building Council of Nigeria for the generous invitation. I'm deeply honored to be able to present on this topic, which I'm quite passionate about, but also I'll be happy to have some conversations with you, especially with setting the context. So thanks for this great opportunity. Today I'll be talking about understanding on life carbon in building. I literally will be keen to cover what it is, why it matters. I will be talking particularly about the EN 15978, which is a standard that is specific to buildings. And I'll be talking about the embodied and operational carbon. I believe that there might be a time for questioning at some point, but in general, this is going to be the scope of my talk. I will try as much as possible to provide a little bit of a context and the background, and I'm hoping that this will lead us into understanding the whole concept of whole life carbon. I will talk a little bit about global warming potential, and then this will lead on to looking at some of the methodological processes into how this is calculated. I'm hoping that this would help us, and this would be a useful segue to touch on life cycle impact assessment. And I would be particularly focusing on our life cycle assessment, which again is my expertise, will be supporting this carbon accounting today. And in general, I would be suggesting a process for completing a life carbon assessment and just providing some excellent guide documents for people that may be interested with knowing more about this. So thank you so much, Chair Usman, for reading the citations. I've sort of just put a little bit of a QR code. I would be happy to connect with you if you are interested in further details. So please feel free to scan the QR code if you get the chance or if you want to connect with me. It is important to state that the exact emissions that Nigeria has at the moment is a little bit debatable. I did a little bit of research on this, and you and the Green Building Council of Nigeria may have strong opinions about this. But what I actually found out while I was looking at this was that at the moment, we are in a situation whereby we typically have approximately 300 million tons, or that is what we do generate. And I would say that in particular, the building sector, which is where we're talking about, contributes about 22% of the greenhouse gas emission, which is kind of lower than what we do have in the West, where we do have 40% generally, and that is the estimate of UNEP. But nevertheless, I actually found that the Climate Policy Initiative in 2023 estimated that buildings in Lagos are responsible for 55% of CO2 emissions. And majority of the emissions in Nigeria and from buildings is actually attributable to our use of oil and natural gas. And you potentially would agree with me that also we do have high energy use in buildings in Nigeria. And that is really because we do not take advantage of passive designs as much as we could. Nevertheless, it's not all grim news. You can see that buildings in general just account for just around 30 million tons. So if we look at that number very well, it feels like it's not a whole lot of number, but I would just want to set a little bit of a context to look at what is going to happen in the next 30 years, as well as what the demand for buildings are, and that would help us. But this is sort of the data that I could find. And I'll be happy for people that may have more updated data to be able to share that as well. Now, moving on to this, it is important for me to just mention that Nigeria is actually expected to double its population and become the third largest country in the world by 2050. And this implies that our urban population, as you know, much more than I do, is growing at an annual rate of 5.5%, which effectively means that our need for buildings will be increasing. And this actually means that we will be needing at least 700,000 units annually per year if we are going to be able to meet our housing needs by 2050. So when we talk about whole life carbon, which is effectively what we're talking about today, we would really be talking about two aspects of it. And that would effectively be the embodied and the operational carbon impact that we do have in building. So this is sort of a slide that comes from Green Building Council of Australia, as well as ThinkStep, which is one of the leading life cycle assessment consultancies. And it's very interesting because you can see that particularly all the areas in what you call violet color is more or less about the embodied carbon. And then when we talk about our operational carbon, we're really more or less talking about what we do use for our water and energy resources. So being put together, we talk about our whole life carbon, which brings together our embodied and our operation carbon impacts. Now, you probably would notice that there's a part that is gray, which is sort of out of scope and realistically so. So I will talk about some of these modular stages, particularly when we get to EN 15978. So please bear with me. Now, why is this important? And I think it is important we should go forward. I just really want to quickly talk about global warming because this is sort of a very important thing for many of us to sort of understand. Again, climate emergency is the language that we speak about now. And the metric we often use for measuring our climate change is really what we call greenhouse gas emission. So you can see that this is what we talk of and we call global warming. Now, when we talk about global warming, there are actually many gases that contribute to global warming, but the one that is perhaps the most important one, or what I would say the most common and the one that we understand most is carbon dioxide, okay? However, we actually have, if you don't mind me say, more severe and more dangerous gases. So we have, for example, methane, which often comes from cooking gas. And if you don't mind me saying, methane has a multiplier effect of 28, according to the IPCC fifth edition. And we also know fully well that nitrous oxide has a multiplier effect of 265. This used to be 310 a couple of years ago. So this implies that we try as much as possible to measure what is going to be the carbon dioxide equivalent over a 100-year time scale. And that is why we'll focus on it. Now, if you look at the diagram I've put before you, you are going to see that there are quite a number of things that happens before we talk about global warming potential. We often have these gases that they are emitted over time, they get to become concentrated, they kind of lead to what we call radiative forcing, and then we start to experience climate change. And so you can sort of start to see the impacts, that this impact spread to not just humans, but ecosystem. And that is why organizations such as the Green Building Council of Nigeria, you make a very strong advocacy group to be able to support us to be able to solve the problems of climate change. Now, as the focus of this particular talk is more or less trying to look at how we can calculate it, I will try as much as possible to talk about EN 15978. And I think this is a very important standard that I would encourage you all to acquaint yourself with, especially as experts in the field. The EN 15978 is effectively talking about how we can assess environmental performance, and it provides a very elaborate calculation method for us. So you can see that the embodied carbon are particularly those that are shown in yellow color, which will cover modules A1 to A5, which is the product stage and the construction stage. And you can also see that it covers B1 to B5, which is going to be the use, the maintenance, the repair, the replacement, as well as the refurbishment stage if necessary. But it also goes into C1 to C4, which talks about, transport, waste processing, and disposal. The good news is that EN 15978 also provides some default scenarios. And this is very useful because when we build an asset or when we erect an asset, we might not know exactly what would happen in the end of life, but this particular standard would give us default scenarios that are acceptable, and I would encourage you to look at it. Operational carbon, as you can see, talks about the carbon dioxide associated with in-use operation of the buildings, which is going to be B6 and B7. And you can see that in this instance, it talks about things like carbon emissions from heating, hot water cooling, ventilation, and lighting system. And you would perhaps notice that some of the important things here, which we don't really have in Nigerian buildings, not many and not every building actually has things like heating and hot water. We typically do have things like cooling and ventilation, but this is sort of part of the reasons why our emissions are a little bit much more reduced than what we do have in the Western nation, whereby we do have huge swings in temperature, and this is why it is very useful. Now, I just really want to quickly draw your attention to the flowchart on my right, and you can sort of see that whenever we want to use our EN 15978, it is important for us to be able to define effectively what's the goal of our purpose is. We need to have a bit of a functional unit. We need to be able to, if you don't mind me saying, disaggregate our model. So look at it from looking at the whole building as it is, disaggregate them into different parts, the foundations, the structures, and different parts. And then we need to go into the bills of quantity to be able to calculate them. Should, in case we don't have a generic data, we need to know what are going to be the secondary data sources. And after we've been able to do this, we sort of will be able to bring all of this together. So this is sort of what EN 15978 tells us. The last edition was released in 2011, and I believe that it will be updated soon. Now, a lot of you would have heard about life cycle assessment, and many of you would have also heard about what we call carbon accounting. Now, life cycle assessment in itself is a very robust process. It effectively tells us of how we can quantitatively evaluate the environmental impact of products. But within the life cycle assessment methodology, we actually have 4 stages. And these 4 stages are the goal and scope definition, the inventory analysis, the impact assessment, and the interpretation phase. For the purpose of carbon accounting, we're just going to focus on the 3rd phase. And that's not because we don't really do the other phases, but because we're centering on carbon, I would pretty much explain what happened. So if you look at it very well, what we will be doing, and this is part of what we're going to be looking at in the breakout today, is that we're going to be looking at how we can compile this inventory together. And so if you look at carbon emission, you can see that this is looking at the fossil fuels we burn, the industrial production processes, and land use change as well. You can see that methane oftentimes comes from agricultural activities, but it also comes from cooking gas as well. So for many of us that will use natural gas, to cook, then methane oftentimes is released, and sometimes it's actually leakages that actually happens in many cases. But we also have what we call nitrous oxides, and this one really comes from the use of synthetic and organic fertilizers in different ways, but there are also different chemicals to it. So if you put all this sum together, you can see that, if you release 1 unit of each of these, you can see that we already have 294 kilograms of CO2 equivalent. So this tells us that our life cycle impact assessment helps us to model quantitatively, the complex interactions between a product or a building and its environment. Now, you would wonder that why do we use, so life cycle assessment is not restricted to carbon accounting alone. We have some other 10, 15 different indicators. Ozone depletion potential is there, particulate matter is there, abiotic depletion is there, human toxicity. We have quite a huge spectra. But the real emergency we have at the moment, which is sort of the one we have to deal with now, is carbon accounting. But life cycle assessment goes beyond just carbon accounting and covers a spectra of other resources. Now, we aim to round up in about 3 minutes, just so that I keep to time. So the process for us completing our whole life carbon assessment, and this is taken by the RICS guidance note published in 2023 in the United Kingdom. So we need to initiate our assessment, which means we need to define our project scope. And this is really important because sometimes we want to focus on just one element of the building, maybe that is the roof or the floor or just the brick, but sometimes we might also expand this to the building. A lot of times our BIM model or our bill of quantities is a very useful sort of our inventories, but that in its native sense is not sufficient enough for us to be able to get our inventory. So we need to be able to translate these material quantities and then quantify them as what we call life cycle inventory data. And that takes us to step 3, where we quantify the data. Then this moves on to step 4 to step 6, where on a modular basis, based on the EN 15978, we'll calculate each of the emissions for all of those stages, and then we will be able to compile the report and develop the assessment. So for anyone that may be interested in finding more about this, I will recommend these excellent resources. So the first one is the RICS professional standard, which is whole life cycle carbon assessment for the construction or for the built environment. The second one is by the Institution of Structural Engineers, again in the UK. And this one gives you a guide about how to calculate embodied carbon. And the last one is from KPMG, which talks about embodied carbon management for global infrastructure. So I would recommend all these resources for you, should in case you need a reference document to be able to calculate or to be able to estimate whole life carbon assessment in buildings. So thank you very much. I'm happy to pass on to the moderator. Thank you, Chair Usman and the President, Danjuma.
Thank you very much, Dr. Buki Tokede, for the excellent presentation. We go to, I think before we go into question and answer, we're actually supposed to go into a breakout session to be able to calculate this carbon, embodied carbon. And I think we will need a guide for us to be able to do that. Can I invite Mohammed Abdul Salam to just give us a run through of how to calculate this carbon before we go into the breakout session?
Thank you very much, sir. I was thinking the breakout session would have been like the best place. But yeah, I will just share my screen.
No, just to give us an introduction into it. And when we go into the breakout session, we're going to have each of the facilitator guiding the members in that breakout room.
Yeah, I'm just going to share. Can you see the breakout document?
Yes, yes, yes.
So I'm just going to give a rough, a brief explanation. So the breakout exercise will focus mainly on the upfront carbon, which is the A1 to A5. And so that would mean we'll calculate the A1 to A2, which is the product stage, the A4, which is transportation of material to site, the A5, which is installation of those materials on site. So we would convert, let me just scroll here. So we have 3 materials to look at today. We have, and the equivalent of the gases that each material emits has been given in terms of kg. So we have for CO2, for methane, and for nitrous oxide. So we would convert these into carbon CO2 equivalent, and then convert them into the material weight, or adjust them into the material weight, and then we can look at converting for for the transportation as well. That's converting the material quantity, the transport emission factor, and the distance the material travels before it gets from the manufacturing site up until installation on site. So we'll do that to get the A4, and then we'll add everything together with the A5, and then we can get our A1 to A5. And then we'll look at different scenarios at like changing the transport location, or for example, in this case, we would look at 150 kilometers to 50 kilometers for the recycled concrete block. And then another scenario is looking at 20% cement replacement. So this can be fly ash or GGBS, that's ground granulated. Sorry, I can't remember the other ones here, but we'll look at also the policy part of it, and then mix modification part of it as well. And then we'll go into discussions on what we think about everything. Yeah, I think we can just go into the breakout now, and then the facilitators will explain better when we get there. I've just done like a very brief explanation.
Thank you very much, Mr. Mohammed. So there's a document in the chat box for us to use for this exercise that we're going to do. So I will encourage us to look into the chat box, download a copy of this document, which we will use during the breakout session. We're about 80 on the call. We'll go into about 4 breakout sections, and each of these sections will be led by the facilitator. So we're going to have group for Dr. Tokide, we are going to have a group for Dr. Sami, have a group for Mr. Mohammed Abdusalam, and another one for our lead consultant architect, Sangita. Can we, the secretary, give us the breakout rooms? We indicate the breakout room. Welcome back from the breakout session. It's really been a very interesting one. I'm sure we all had a good time with our resource person on how to calculate carbon in building. And I'm sure we now have the ability to be able to calculate it ourselves and be able to assess which material has what emission, depending on the different scenario that we have looked at. So now I think we back now to can we have summary of the breakout session from our resource person? What are the things you experienced based on your interaction with the people in your group? I'll start with Dr. Tokede. What is the takeaway from your group?
Well, I think we found this session interesting. Unfortunately, we were not able to complete the scenarios. We thought we might have been able to get some extra time, but it was quite interactive. We had volunteers within the groups that decided to take each of those scenarios and we calculated it together. So it seemed there was a little bit of clarity with regards to each of those. So we found it quite interesting, and I would mention that it would be nice for us to maybe get a little bit more time next time. But thanks very much.
Thank you very much. Next, we'll go to Dr. Sami. Dr. Sami, you can unmute yourself and give us the summary of your group.
Oh, okay. Thank you. We're able to calculate and got to the total upfront carbon. The conclusion that we're able to drive is that the compressed earth block ranks best, and concrete block ranks second, and recycled concrete block ranks the third. That's one of the inference that we're able to draw from the conclusion of the calculations that we're able to do. And everyone understands. And we hope, just like Dr. Tokede said, we hope that we're going to be able to get more time next time, but we are able to at least get to the point where everybody understands what we're talking about. And I believe that they can handle it by themselves, play with the different scenarios and get, what's it called? Get different opinions as to the ranking based on the different changes that could happen to their respective project sites based on the type of material they want to choose. I think that will be it from my side.
Thank you very much. Next, Sangeeta.
Thank you again. I didn't give much time to my audience to talk because we were very busy calculating. Yes, we also got an infer on the materials we happen to calculate, but I think few of my breakout people have some questions to be asked. So we also inferred the concrete blocks. We calculated from A1 to A5, of course, and the J box, and we ranked them as well. And I explained the scenarios on what scenarios and what are the key strategies that we are using to identify and the influence of our upfront carbons of each materials. But they do have some questions. I think we didn't have the time, so I told them to keep their questions for the main session so that even their questions can be answered, which will be useful to the other participants. Thank you.
Thank you very much. And lastly, Mohammed, can we have your wrap up from your group?
Yeah. I think the problem is same all around time. But yeah, we're able to calculate the upfront carbon for the three materials, and like Dr. Sami said, we're able to rank them from compressed earth block being number 1 and concrete block being number 2 and recycled concrete block being number 3. We're able to do 1 or 2 scenarios, but unfortunately, we could not conclude. I don't know if anyone has questions, but we discussed that if anyone has a question, we can talk on the main forum. I think can't remember. Someone asked a very good question. But yeah, if I remember, I'll bring it up. But yeah, it was a very good session.
Okay, thank you very much. Thank you, our resource person. We appreciate your time, your expertise. I think we can now take few questions, maybe about 3-4 questions from the audience, your experience in the group, what questions you need clarification on, and so that they can address it. If you have any question, please raise up your hand. You can unmute yourself and ask the question, please. While expecting, hello?
Yes, I have a question.
Please go ahead.
This is Valentine, my name, Valentine Amamogo. My question is, what we have calculated now is basically about walls as well. But we equally know that, especially in the case of Nigeria, we use a lot of paint here. Unlike building, where you can see that you have to have some level of manageable pockets to build a house, to mold a block. Every tenant paints in and out. And I'm wondering if there's a way to calculate the carbon emission in paints. Basically, that's my question, because I believe that, well, I think that the percentage of carbon that will be coming from paint in Nigeria is very likely to be very high. Probably, I don't know. But anyway, that's the question, really. Thank you.
Thank you very much. As you have noted, we just pick an element of the building, which is the wall. Every aspect of the building have their own embodied carbon, and they can also be calculated. I don't know if any of the resource person will want to take that question.
Yeah, I based on my understanding of the question, I think he's probably talking about the fact that people repaint maybe every 5 years or something like that. And yeah, the impact of that. So that's where I guess the B module comes into play, the replacement and repair. So and I think I explained in my group that so if we use the stool as an example, as a description, the manufacturing of stool, that's cutting down of the wood, that will be the A1, and then transferring that to the manufacturing side, that will be the A2, and then manufacturing of the stool itself will be the A3, and then A4 to site, and then to the construction site, and A5 installation on site. So I explained that if the stool has, let's say, service life of 10 years, so that means it will be replaced every 10 years. So that's where the B module will come, because the B module is essentially the replacement emissions will essentially be that A1 to A5 multiplied by, if it's every 10 years, that's, and the building life is 60 years, that will be it means it needs 5 replacements for the building life during the building life. So that will be essentially A1 to A5 times 5. I hope that makes sense.
Yeah, thank you. I think it's straightforward. What we have concentrated on in this webinar is A1 to A5, but as clearly explained by the Dr. Tokede in his earlier presentation, there are other modules where we can also calculate the emission from there. So, but our concentration is on A1 to A5, but of course, during the operational carbon is also there, the replacement is also there, and even end of life can also be calculated. But our focus on this webinar is just for the A1 to A5. I think that's clear to the question. Yeah. Can we have Felix? Please go ahead. Felix.
Sorry, before Felix, can I just add one thing to that answer?
Okay, please go ahead.
Yes, I wanted to, because what the question he asked is very peculiar, and talking about paint, there is one thing to also note, because there is the aspect of off-gassing. And the off-gassing is where you talk about the VOC, that's the volatile organic compound. usually it's the chemical that evaporates easily at room temperature that definitely also releases here into the atmosphere and contributes to the GHG. So when you are doing the calculation, just like you have done for the block wall, what you also need to consider when you are doing for painting is the off-gassing, which is an indirect effect of the paint. And that will also now be included in your entirety of the calculation that you want to do. Thank you.
Thank you very much for the additional clarification. So Felix, go ahead.
Yeah, thank you very much for this session. I really enjoyed the numbers, but I didn't.
Please speak louder. We can't hear you.
Yeah, I'm saying I enjoyed the session, and what I and also what I'm not sure is where the data is reliable.
I don't know whether other people are hearing you. I can't hear you clearly. You are not audible. Hello?
Can you hear me?
Okay, fair.
Yes.
Go
So
ahead.
I was saying, where do we get this constant that we are using to calculate?
The audio is going on, it's fluctuating.
Yes, it's really fluctuating. We can hardly make sense of what he's saying.
Okay, let's try other person when we can come back to you. Show me, William.
Maybe he can type
Good
his
afternoon.
question in
Can
the
you hear
chat.
me?
Oh, okay, that's true. You can try your question in the chat box.
Good afternoon, all. Can you hear me?
Yeah, we can hear you.
Okay, thanks for the seminar. I just want to find out what's the link between this carbon calculation and certifications like EDGE, and also the link with this with sustainability reporting 1 and 2. I need a broader explanation. So that's my question.
Well, Dr. Tokide, will you want to take that?
Okay. Well, given that I would say a couple, well, I probably am not completely familiar with what you have in your EDGE certification, but I can obviously talk about a little bit of what happens in scope 1 or scope 2 reportings. Okay. So if you would like, perhaps I would say maybe the in-house consultants. Is it Samantha? She might be able to respond to that a bit better. A lot of certification systems, again, the ones I'm most familiar with are more like the Green Building Council certification. Carbon accounting, or what I would call whole life carbon assessment, is particularly useful, especially when we're thinking about scope 1 and scope 2 emissions. And I don't know, maybe you understand what scope 1 and scope 2 emissions in, but I'm happy to define that. But they wouldn't touch on scope 3 emissions. So that's sort of what I would basically say. But I would need to look more into what is into the EDGE certification to know how there's a link to be able to accomplish that. So apologies if maybe Sanjita may know more about that, and I'm not putting you on the spot, Sanjita.
No problem. Thank you for that. I'm an EDGE expert, so in terms of these carbon calculation, is as far as EDGE certification, there are 3 main categories: the material, the energy, as well as the water. When you calculate the whole carbon of it, you basically have influence on choosing your material, the most sustainable material. So when you identify this calculation for one of the material and you find it is much lower than a conventional material, you will be of course taking a more savings, which will actually give you a higher percentage in terms of material, and of course you will have a reach higher certifications, that is either advanced or more net zero certification when it's come to EDGE. When you're calculating this, it also has an influence in the energy. So the materials used by an energy is also accounted. So you will have a consideration amount of what do you call as cross-cutting or synergy inside, where you will get much less embodied carbon in material as well as in energy. There is a slight influence of water usage in the materials that you're producing as well. So there will be a slight indicator of that. So that is in terms of green building certification. So basically when you to put it in one line, when you use more less embodied or more environmentally friendly or less embodied carbon material, you increase a lot of points in that category, which will eventually give you a higher certification. That is first. The second one, you're asking about reporting. Reporting is basically you are reporting, so we have to take it to sector specific to understand this. So if we use, let's imagine we are all in a building sector. So if you're using a building emission, so your products and their carbon footprint will be your scope 2, because like your building will be scope 1, the energy that it consumes, as well as the products that you use will be scope 2. So your scope 2 carbon footprint will be reduced. So that in turn will make it more impactful. So basically, reporting is basically you're reporting your GHG emissions of scope 1, 2, and 3. This will basically comes under scope 2, which is purchased carbon emissions. So in that you can reduce this, so which in turn will give you a better reporting, basically better reporting in a sense, better reduction in your reporting in scope 2 emissions. I'm sorry, it's a big topic. I'm trying to concise it into a small one. I hope it answers you.
Explanation. We'll take the last one. Adedamola, please go ahead. Adedamola.
Thank you, sir. Hope I'm audible, sir.
Yeah, you are.
Yeah, thank you. Thanks for this opportunity, sir. Yeah, I was when I was preparing for this lecture, I think I came across the type of cement that we usually use in Nigeria, and I was trying to link it to the emission level. I think we use typically the OPC and the PVC cement type, and I want to know, because I got to know that some of them have higher and lower emission rates when it comes to CO2 contribution. How are we enforcing, or if we can adjust or make use of one particular type more than the other, and it won't affect cost, because cost is implication too. Then two, even if we can't do all this calculation for building now, is there any policy we can run or make in Nigeria that, even starting with maybe corporate company or something, that even all this calculation must be done for their buildings or something, so that we can really contribute in the future? Thank you, sir.
Thank you very much. Can I put Dr. Sami to help us address this?
Okay. All right. To probably just add a few contributions to that. Talking about the relationship between sustainability and cost. I mean, that's one important thing to note. There is the misconception. For me, I always call it misconception. There's this misconception that sustainability is expensive, but in reality, it is not. It is a matter of choice. It's like you deciding to either go for a marble or decide to go for a tile. One probably might be expensive, but in the long run, you have to replace it 2 times before you replace the other one that is not that expensive, but just because it has an extra 10% on top of the cost as at today, you think it's expensive, but you have to use that for maybe 20 years. The other one you use it for 10 years. And the difference in cost is maybe like 10%. So it's relative when you're talking about sustainability and cost. That's one side. Then the other flip side of the conversation that we have also experienced today is the embodied energy. Because when you're now looking in the direction of the embodied energy, you would see that there are a whole lot of different things that contribute to the footprint of that particular material, one of which is transportation. And when we are talking about transportation, what that is saying is that the closer you are to the material, the easier it is for you to have a more or less carbon-oriented material. And that means that you would need to spend less on transportation as well. So if you look in that direction, then you would see that sustainability in that side is directly proportional to low cost. So, and there are some areas as well that you would find it difficult to get maybe some of those materials. Maybe the recycled materials is not currently in large quantity, it's not in commercial quantity. So you probably have to go far away before you probably get those materials. In that situation as well, you might be looking in the direction of, oh, okay, cost is relatively going to be high when you are considering this type of material. So it depends on the peculiarity of the project in which you currently have. And that's why it's very important for you to have maybe an LCA analyst to probably look in the direction of, these are the material choices that we have. These are the alternatives that we're also looking at. What do you think is going to be the game changer for us? So they can help you analyze all of those things, put them side by side so that you can have an holistic view of what it all looks like. Then you can relate it directly to the cost as well. At the end of the day, you would find out that it might not necessarily have to be expensive, but we just always have that mindset that sustainability is expensive. So I would like us to have a change of heart in that direction and start looking in the direction of, we need to prove otherwise. So it is when we prove it, that's when we'll be able to say, oh, okay, yeah, truly it is expensive. And maybe because of that, you might want to go for maybe the one that ranks second, or maybe the ones that rank next in line with your different alternatives that you have.
Thank you for that, Dr. Sanvi. Please, if I can add, as what we did today is LCA, that is life cycle assessment. When it comes to cost, we also take, that is also a serious concern. So there is something called LCC, that is life cycle cost as well. So it also gives you the holistic cost, how it gives the holistic imprint of carbon, LCA. LCC also gives you the holistic cost of right from extracting your raw materials, your production, your transportation, the operational cost, as well as the end of life and also the recycling cost as well. So that can also be calculated in the same manner with a lot more information, and that will give you the, as Dr. Sanvi said, that will also give you as it will give you each material, the carbon footprint, the emission, as well as the costs related to it. So which will give you a better understanding and make a decision on based on both of it, on which you want to bargain and give up in. And I think the second question is on, is there any other policies on making a mandate in terms of encouraging this LCA calculations for material? I wouldn't say any government policies, but all the certification systems directly or indirectly will ask you to do an LCA. That is when it comes to EDGE, it's indirectly because it's an app which has already assumed the emissions for your basic material. When it comes to other certifications like LEED or BREEAM, you have to do an LCA to prove that you are having a less carbon footprinted material in your building to claim for higher points. So all the certification systems has this as a major criteria.
Thank you, Sangeeta,
Thank
for the. Yeah, I think that really answered the question about it's really not a government policy, but an advocacy that in order for us to address the climate change, we need to design our building in accordance with all these certifications so that we have a building that are more resilient to climate change. Dr. Tokede, you still want to have something to say?
Well, I just wanted to quickly add that, please, in Australia, based on the policy of the government, and so I think the GBCN has some work to do, particularly with shaping policies. What the government has done is that for you as a supplier, you need to have the environmental product declarations, which is verified, third-party verified life cycle assessment reports. And this means that, you are forced, if you want to win big projects, you want to be a supply on major projects, then you are forced to be able to, improve your emissions. And I just wanted to also quickly add that ordinary Portland cement is sort of very carbon intensive, but we also have materials which are like fly ash, which are cement replacing materials. And you can actually realistically replace them by up to 30% without compromising on the structural integrity. And even if you have things like GGBS, which is granulated blast furnace slag, which someone mentioned, you might even be able to get to 70%. So I would say, particularly in the Western world, fly ash as well as GGBS, they are things that are often used to minimize the cement we use in our products. So thank you so much, Chair. I just wanted to add that.
Sorry, I also wanted to add on the policy side of things. There are a couple of countries now that LCA, before any building project is done, is mandatory to carry out a whole life carbon. I can give an example of the UK, London to be specific. For any new building projects that goes into planning, you need to submit an LC, a whole life carbon alongside your planning application. So I guess that comes in terms of the policy aspect of things. I don't want to make this too complicated on the GGBS discussion, because GGBS is yeah, like in the UK now, it's becoming very difficult to get cement with GGBS, concrete with GGBS, because most of the steel, the blast furnace steel manufacturing plants are closing down. So not enough GGBS is being produced to replace the cement with. So it's a whole lot of conversation now. But yeah, there's a lot. Yeah, thank you.
Thank you very much. This has been really a very interesting webinar for us today. I'm sure that we have all taken one or two out of our webinar today. So we have to wrap up because we are supposed to end the call by 2:30, but I'll just give some information. On the chat box has been the link to membership of GPCN has been posted. Please, we want you there to join us in this advocacy for a green building practice in Nigeria. So join us in this advocacy job that we're doing. We want you to be part of the process. Then, so the membership flyer is shared. We can take note of that. If there are other questions, please, you can send to GPC and we will take them and respond to you quickly. I don't know if the president have a final word for us. Mr. President.
Yes, thank you, engineer. No question per se, just to say thank you to everybody for giving us your time this afternoon, and just to reiterate what we shared earlier. This is kind of just a teaser. You understand, we try to compress a lot into a very short period of time, but we intended this as a teaser. So we have a course that we offer that takes you through the whole process. It's called the Certified Carbon Assessment Professional Course. We'll be running the next cohort. I can't say exactly because we're revamping the course now. It's about 2 years old, so we need to update the material. But probably December or January. It's based on the RICS Whole Life Carbon Assessment framework. So that will take you through the whole process. And because it came up here, it's important that we understand there are dynamics and there are feedbacks and interactions we need to consider in this thing. One of the ones that came up was transport distance. But because we only looked at one building assembly, we didn't really consider potential linkages and impacts with other building assemblies. For example, your choice of your external facade material can impact your structure. So those are the kind of things that is why we talk about using a whole life perspective, so that you see what your decision on your wall has on your roof, on your structure, and so on. And you take even a whole life perspective, as mentioned. My choice for CEB may be the lowest from an embodied carbon perspective, But when I consider maintenance, replacement, and so on, is it actually the lowest carbon choice? So when we are ready to run the course, we'll let you know. Keep an eye on our social media pages. And once again, thank you, everybody. Back to you, Engineer Usman.
Thank you very much. In addition to what the president has done, I want to appreciate our resource person for giving us their time and the expertise to share with us on this call. It's really been a very nice one. This is the first time we're getting almost about 100 participants attending our webinar. It's very, very interesting. I want to thank you all for creating time to attend. And please join us in GBCN. We welcome you for us to work together to continue the advocacy for green building practice, climate change resilience, and all whatnot. So we welcome you all. If there are any other questions that you have, particularly on this webinar or anything, please do reach out to us at our websites, our social media handle. We will be ready to provide solution to your question as much as we can do. Thank you very much. Do all have a lovely afternoon. And for Dr. Tokede, sorry we kept you awake. Thank you very much for sparing your time. We really appreciate your time. Thank you very much, everyone. Do have a lovely afternoon.
Thank you very much. And bye, everyone. Thank you.
Thank you, everyone.